Hi students, in this video I'm going to do remainder and factor theorem. There will be a variation of questions from basic to advanced, so please stay to the end. Right, let's look at what are the concepts that we need to have in this chapter, polynomials. Let's look at how we can define the degree of a polynomial. So the degree of a polynomial is the largest, which is a whole number, the largest index among all the terms. For example, if you have a polynomial that is 2x cubed plus x to the power 5 plus 3, then you will see that the largest index is 5. So in this polynomial, this is of degree 5. And the degree of a non-zero constant polynomial is 0. For example, the degree of 4 is 0. Why is that so? Because we can actually write 4 times x to the power 0, and x to the power 0 is 1. Therefore, the degree of a non-zero constant is 0. The degree of, another example, the degree of 5, let's say, it's 0. The degree of the number 6 is also 0. So on and so forth. Okay, what other concepts is involved in this chapter? Yes, the remainder theorem. And what is the remainder theorem? It states that if you're given a function, and if this function is divided by ax minus b, then the remainder that you'll get with this function is f of bracket b over a close bracket. How do you get b over a? Basically, you just let the divisor equals to 0. That means you let ax minus b equals to 0. You add b on both sides, you end up getting ax equals to b. You divide by 8 on both sides. That's how you get b over a. Right, so you're actually substituting your x to be b over a, and that is where you get your remainder. R stands for remainder. Likewise, if it's divided by x minus a, if you let x minus a equals to 0, you're substituting the values of x to be a, and f of a will give you your remainder. So this is remainder theorem. Right, so in polynomials, we also need to learn factor theorem. Basically, factor theorem is derived from the remainder theorem. Factor theorem is such that when the remainder is equal to 0, and that happens only if and only your divisor, if and only the function is exactly divisible by the divisor, or your divisor is a factor. So in both situations, it gives you remainder equal to 0. So that is factor theorem. And in factor theorem, we also need to learn the sum and difference of cubes. Right, because you need to learn how to factorize a cubed plus b cubed. That is called sum of cubes. A cubed minus b cubed, that is called difference of cubes. And we need to learn how to factorize cubic polynomials, as shown on the screen there. Different steps to do it. Basically, for step 1, we usually use the calculator to help us to find one value of x that satisfies the polynomial equation, and then we convert it into a linear factor. And then for step 2, we write it as a linear factor, multiply with a quadratic factors, and we find all the unknowns a, b, and c. Right. And of course, we also need to know how to solve cubic equations. And we do that after factorizing the cubic polynomials, equate it to 0 to find the values of x that satisfy the cubic equations. So these are the concepts needed in this chapter, polynomials. Right, let's look at the basic questions involving remainder theorem. Supposing you ask to find the remainder when this polynomial 8x to the power 4 minus 2x cubed plus 5x minus 2 is divided by 2x plus 1. So how do we go about solving it? Yes, first thing, we'll give it the polynomial a name. We're going to call it f of x, right? So remainder theorem tells us that if I'm going to substitute my x to be negative half, that will give us the remainder. In other words, f of negative half will allow us to find the remainder. And how do I get negative half? That is when I let the divisor equals to 0, and you'll get 2x equals to negative 1, x equals to negative half. So we're going to substitute all the x terms with the number negative half. And let's see what we get. Right, and if you use a calculator to evaluate this, please don't use mental calculations. In the exam, we're running short of time. So using the calculator is a more advisable thing to do. You will have the remainder negative 15 over 4. Let's look at another basic questions. Right, in this questions here, that's unknown in the polynomial, and that is k. And we are given that this polynomial leaves a remainder of 15 when divided by x minus 2. Right, so according to remainder theorem, when I substitute my x to be 2, the remainder is equals to 15. Right, so how do we go about solving this question? Yes, as what we have done earlier on, we will let this top polynomial be called f of x. So we're going to substitute x to be 2. And then you can use a calculator to simplify this and this. That will give you 2k plus 23 equals to 15. You minus 23 on both sides. That will give you 2k equals to negative 8 and k equals to negative 4. Right, so let's upgrade ourselves. So what we have done are two basic questions involving remainder theorem. Now let's look at a more intermediate standard. So in this question here, you're given the polynomial 2x cubed plus ax squared plus bx plus 6. And basically there are two unknowns there, unknowns a and b, right? So this polynomial is exactly divisible by x minus 3, but leaves a remainder of negative 4 when divided by x plus 1. So let's break down the information into using the factor theorem, because when it's exactly divisible by x minus 3, it means the remainder is equal to 0. And if it's alright, so as what we have done earlier, let's call this polynomial f of x, right? And f of 3 will gives you remainder 0. Alright, so how do I end up getting this one? This is, I got it from the second part of the information given. When it's divided by x plus 1, that means if you let x plus 1 equals to 0, you're substituting your x to be negative 1. So f of negative 1 gives you remainder negative 4. So this is where I apply the remainder theorem. Alright, so I have two equations here which I can generate. Right, first one is to substitute all the x terms with the value 3, equate it to 0, simplify it, divide. Here, what I've done is I divide by 3 throughout to get 3a plus b plus 20 equal to 0. And I make b the subject because I'm going to use substitution method to solve these two simultaneous equations. And the second equation is where I substitute my x to be negative 1 equals to negative 4. And likewise, you can use a calculator to work this out to get 4, right? And this one, negative 1 times negative 1 will give you positive 1. So positive 1 times a will give you a. This is b times negative 1 gives you negative b, right? So I would have a second equation that is a minus b equals negative 8. So I'm going to substitute equation 1 into equation 2. And from there, I can get a equals to negative 7, right? right? Very important thing is to bracket this one here. Okay, each time you have more than one term, you have to bracket it so that there will be a change of sign. Negative times negative gives you positive. Right, and we are not done yet. With the values of a equals to -7, let's substitute into equation 1 to find the values of b. Right, so therefore a is equals to -7 and b equals to 1 for part A. Right, let's look at part B. Part B is slightly harder, right, because you asked to solve the equation and that involves you having to find the quadratic factors. Okay, so what we're going to do is we're going to substitute the values of a and b into fx. Right, and since we are told in the beginning that this function fx is exactly divisible by x minus 3, that means x minus 3 is a factor. So there are two ways of doing it. You can use long division to find the quadratic factor. Long division x, this one here. If you've forgotten how to do long division, please refer to the video. I have done a video earlier on how you can use the long division. I'll put the link in the text box underneath this video. Otherwise, I'm going to show you how to find the quadratic factor using compare coefficients method. Right, so basically your cubic, this is your cubic polynomial, it's equals to linear factor multiplied with a quadratic factor. So this is called quadratic factor. And the quadratic factors is in the format ax squared plus bx plus c. So basically the three unknowns that I need to find, the three unknowns are your a, b, and c. So we're going to find each one of them separately. Right, so if you take the first term in your factor and you multiply it with your ax squared, that will always give you the first term in your cubic polynomial. Assuming that you've arranged the order properly, the power from the biggest, 3, 2, 1, and constant. Constant means x to the power of 0. If you arrange it properly, then when you take x times ax squared, that will give you the first term of your cubic polynomial. Alright, let's see what happened. Yes, so x times ax squared will give you ax cubed, and ax cubed will be equals to 2x cubed. And if you take the second term of your linear factor, which is -3, multiply with the constant terms of your quadratic factor, that will always give you the constant term in your cubic polynomial. Alright, so finding the unknowns a and c are rather easy. The next thing is to find the unknowns b. Right, you can multiply everything out, which is a totally waste of time. Here what I'm going to do, I'm just going to compare coefficients of, if you look at your cubic polynomial here, alright, I have taken care of my x cubed term. That's where I find my a equals to 2. I've taken care of my constant term, which I found c equals -2. Basically, I have two terms here. One is the x squared term and one is the x term. So I can either compare the x squared term on both sides or the x term on both sides. It depends which one you want to compare. So for me, I would choose to compare. Yes, after finding the values of a and c, just fill it back inside to get 2x squared plus bx minus 2. I would like to compare the x term. Right, so the x term, there are more than one x term here. -3 times bx. That's another x term where you take x times -2. So you have to make sure you work out all your x terms. So your -3bx minus 2x will give you the x term on the left hand side, which is this one here. Right, and you can divide by x throughout to get negative 3b minus 2 equals to 1, because x that divide by x will gives you 1. And from there you can find your b to be negative 1. So having found all the values a, b, and c, you can plug it back again into your cubic equation, and we can solve it. Right, so the questions state that leave your answer insert. That gives you a hint that for this part here, in order to find the value of x, you would have to use the quadratic formula. Okay, so the quadratic formula is, you have to memorize it, it won't be given to you. That's x equals to negative b plus minus square root of b squared minus 4ac over 2a. So you sub in the values of b, which is negative 1. Make sure you bracket it, bracket negative 1. Sub in the values of a and c and a here. So the other two roots will be 1 plus minus square root 17 over 4. So basically there are three roots here. One is x equals to 3, and the other two are 1 plus minus square root 17 over 4. Right, let's look at another intermediate questions. In these questions here, you're given a polynomial, and when it's divided by x minus 3 and x plus 1, the remainders are 2 and 3 respectively. Right, and we asked to find the remainder when the same polynomial is divided by another polynomial. Right, so let's write down what you're given. So using remainder theorem, right, if you let x minus 3 equals to 0, so we're substituting for x to be 3, so f of 3 will gives you the remainder, which is 2. And when you let x plus 1 equals to 0, you substitute x to be negative 1. So f of negative 1 will give you 3. So that explains this two parts here. Right, so the next questions we need to ask ourselves is, what is it that you need to find? Right, so what you have been told in the question is, if this polynomial fx is divided by this polynomial, which is a quadratic polynomial, if you expand it, you will get x squared minus 3x plus x minus 3. So this divisor is actually a quadratic polynomial of degree 2. Right, and if multiply with the quotient, you will get the remainder. Right, so what we need to find is the value for this remainder. So this is what the question is asking. Right, so if your divisor is of degree 2, then what do you think will be the degree for your remainder? Yes, the degree of a remainder will be 1. And how do you think a remainder with degree 1 looks like? Yes, the remainder of degree 1 will be in the form ax plus b. X meaning x to the power 1, so therefore it explains degree 1. And a and b are constants that we need to find. Because it could be 2x minus 3, it could be 3x plus 1, right? So it's in the form ax plus b. Alright, so how do we go about finding this unknown a and b? So we're going to use the information given in the earlier part where f of 3 is equals to 2. So basically I'm going to substitute my x to be 3. F of 3 equals to 2. So I'm going to substitute my x to be 3. And you see that this part here will be cancelled off, leaving only 3a plus b equals to the remainder, which is 2. That's how we get the first equation. Right. Likewise, I'm going to substitute x to be -1. So when you substitute x to be -1 here, this -1 plus 1 will give you 0. So you eliminate this chunk of thing here. And what you're left will be a times -1 plus b equals to the remainder, which is 3. And that explains how we form the second equation. And we can solve these two equations simultaneously. And we can find the values of a. How do you solve it simultaneously? Basically, you just add. Take 3a plus b. You can solve it using the substitution, the elimination method, sorry. 3a plus b plus bracket -a plus b equals to 2 plus 3. Right, so sorry, you should not add them, you should minus them. So that the b minus the b will be gone, but 3a minus a will give you 4a here, and 2 minus 3 will give you -1. So that explains how we get 4a equals to -1, and therefore a will be -1/4. So after finding the values of a, alright, we still have to find the values of b. So we can just substitute into the first or the second equation here, because basically we have two equations here, so you can substitute into first or second. And if I'm not wrong, I actually substitute into equation 2, making b the subject. So b is 3 plus a, and since a is -1/4, that will give you b to be 11/4. Right. So after finding the values for a and b, now we can plug it back into our remainder, ax plus b. So therefore your remainder will be -1/4 x plus 11/4. So in this questions here, let's recap the concept. That is, if the degree of the divisor is 2, if it's a quadratic polynomial, then the degree of your remainder, right, would be of degree 1. And a remainder with degree 1 will be in the form ax plus b, where a and b are constants that you needs to be found. So this is how you solve these questions. Right, now let's look at advanced question. This is at advanced level because it needs more higher level of higher order level of thinking. Right, so let's look at part 1. Right, so you're given the polynomial equals to 2x cubed plus ax squared plus x plus b, where a and b are constants, and you're given that your divisor is actually a factor. So if your divisor is a factor, it means that the remainder is equal to 0 using factor theorem. Right, so first part is relatively easy. Right, so all we need to do is to factorize your divisor into 2x minus 1 and x plus 1. And from there, we can actually substitute x to be half to get f of half equals to 0. Substitute x to be -1 to get f of -1 equals to 0. Right, so with that, I can form two equations where I can solve them simultaneously to find the values of a and b. Right, so you can just use a calculator to evaluate this to get to get 3/4, and then you bring it to the right hand side to become negative 3/4. Half times half will give you 1/4 A plus B. So what I've done here is I multiply by 4 throughout. That explains how I get the A here plus 4B equals to -3. And I make A the subject because I'm going to use substitutions method to find the values of A and B. Alright, so we can substitute x to be -1 to form a second equation. Substitute x to be -1, all the x here to be -1, and equate it to 0 because the remainder is 0. Right, so we form a second equation, and then we're going to substitute equation 1 into 2 so that I can find the values of b, which is -2. With the value of b found, I can substitute into equation 1 to find the values of a. Right, so this is how we can manage the part I. Right, so now let's look at part 2. For part 2, we are asked to solve the equation f of x equals to 0. So what we're going to do is we're going to substitute the values of a and b we found in part 1 into your polynomial. Right, so to solve the equation means I need to factorize f of x completely. And since we're already given the quadratic factor, I will just need to find the linear factor. Right, so the linear factor is in the form ax plus b, and that will be equals to, yes, so when you take the first term 2x squared multiplied by ax, that will give you the first terms of your fx, which is 2x cubed. And from there you can find the values of a to be 1. Right, and if you take the last term of your quadratic divisor, which the last term is usually the constant term, multiply with the constant term of your linear factor, that will give you the constant term in your fx. Right, so that will gives you -1 times b gives you -b, and that is equals to -2. So after finding the values of a and b, we can substitute back into your linear factor. Right, and then we can let fx equals to 0. And we can factorize your 2x squared plus x minus 1 further into 2 linear factors to find the values of x. And from there, we get x equals to half or x equals to -1. And from this linear factor, we have x equals to -2. So for this polynomial f of x, there are 3 real roots. One is half, one is -1, and one is -2. So that's how we do part 2. So in the next slide, we'll look at how we can solve part 3. Right, let's look at part 3. Part 3 is rather challenging. We are asked to solve it using the information we have obtained in part I and part 2. So in part I, we have found the values of a and b, and in part 2, we have found the solutions to the cubic equation. So with this information, we're going to substitute into part 3. Right, so the next thing we need to do is we need to rewrite. We're supposed to find this to solve this one. Okay, so we're going to write it in the form 2x cubed plus 5x squared plus x minus 2 equals to 0. Right, so what I'm going to do is I'm going to replace x here with the letter a. Okay, so I'm replacing x in this cubic equation with the letter a. Right, and I'll end up getting 2a cubed plus 5a squared plus a minus 2 equals to 0. Alright, and look at what I've done here. I've specifically included a bracket. Alright, why do you think I want to do that? Let's look at the next step. Right, the next questions we need to ask ourselves is, we need to find the values of a. That means I'm going to do a comparison of what you need to find with what you have to determine the values of a. So in other words, what we are saying is these two equations are equivalent. Okay, let me erase too many things here. Right, so what we are saying is that this equation here is actually equivalent to this equation. Right, so when they're equivalent, what we are saying is that the x cubed term, right, this x cubed term, it's equal to this x cubed term. This x squared term will be equal to this term will be equal to this, and of course negative 2 is equal to negative 2, equals to 0, and 0 is equal to 0. So I just need to compare the first term. Okay, the first term, it's 1/4 x cubed equals it to the first term, which is 2a cubed. And from there, let's see what happened. Yes, right, so a cubed will be 1/4 x cubed divided by 2 gives you 1/8 x cubed. And to find the values of a, we just need to cube root 1/8 x cubed to get half x. Right, so in part 2, we have found the values of x. But since I've replaced the letter x with a, we're saying that the values of x we found in part 2 is the values of a, and which are halved, -1, and -2. And I'm going to replace a with half x, because this is the relationship that we have got. So replacing a with half x, we will have half x equals to a, and to find x, you just multiply by 2, which means you just multiply all this answer with the number 2. So that will give you 1, -2, and -4. So 1, -2, and -4 would be the solution to this cubic equation. Right, another important concept in polynomial is to be able to factorize a cubed plus b cubed. So a cubed plus b cubed is called the sum of cubes. And to factorize it, it's actually equals to a linear factor a plus b and a squared minus ab plus b squared. A squared minus ab plus b squared is an irreducible quadratic factors. So this is called the sum of cubes. And the other one is called the difference of cubes, which is a cubed minus b cubed, and that is equals to a minus b, bracket a minus b, times a squared plus ab plus b squared. So it is important that you memorize these two formulas correctly, right, so that you can actually use it to factorize problem sums like 8 plus x cubed, or 27x cubed minus 1000. So in the next slide, we're going to see how we can apply these two formula. Alright, so let's solve these two questions using the formula. So if you look at the first one, the operation is a negative. So we'll be using the difference of cubes. The second one, the operation is a plus, so we'll be using sum of cubes. So let's look at the first one first. So the first one, we can actually express 64 as 4 cubed. And we can combine them into bracket. 4x to the power 3, likewise for 27 is 3 cubed, y cubed, combine them to be bracket 3y, close bracket to the power 3. Alright, so the next thing is that what we're going to do is, I'll be replacing 4x with a and 3y with b. Alright, and then let's put in the brackets. So we will have one bracket for your a minus b, and another bracket for your a squared plus ab plus b squared. Okay, so what do we substitute inside here? So I would have to substitute a here, b here, b, and of course the first term is your a minus b. Alright, so now we can plug in the values for a, which is 4x minus 3y, squared your 4x plus 4x times 3y, then square your 3y. Okay, and we need to simplify it. You cannot leave the answer as this. So 4x times 4x will give you 16x squared. And 3y times 3y gives you 9y squared. So this is how you do the first one. Alright, so for the second one, similarly, we can rewrite 125 as 5 cubed, x cubed, combine them to get this. 64 can be expressed as 4 cubed, right? Okay, and the next step is the same. Put in the brackets. So we have one bracket for your a plus b, because we're using sum of cubes. And take notes of the sign. If we're using sum of cubes, it start with plus, plus, minus, plus. So it's plus, plus, minus, plus. If we're using difference of cube, then it starts with minus, minus, plus, plus. Okay, so that's the difference. Alright, so now we can fill in the value for a and b. Alright, then we can simplify 5x times 5x to get 25x squared minus 20xy then plus 16y squared. Okay, so this is how we can use the formula to factorize your sum and difference of cubes. Right, so let's look at an intermediate question. Right, this question is intermediate in the sense we cannot actually express 16 as a perfect cube. But if you look at 16 and 250, that's a common factor 2, where you can extract it out. So once you extract it out, and then what you're left here is 8x cubed. And of course, then 8 is a perfect cube. You can rewrite it as 2 to the power 3. Likewise, for 125, you can rewrite it as 5 to the power 3. So sometimes for questions like this, you may have to do one additional step, and that's to factorize the common factor before you express the remaining number as perfect cube. And because the operation is a plus, we'll be using sum of cubes. So let's write down the formula first. So the formula for a cubed plus b cubed will be a plus b times a squared minus ab plus b squared. Alright, so let's put in the brackets. Okay. Right, so we'll be substituting a with 2b. This will be your values of a, and substituting b with value 5y. So we have 2x plus 5y. Right, and simplify further.
Alright, so this is how you do this question.
Right, so now let's look at the last part of the concepts that we need to know in this chapter, polynomial, and that it's able to factorize a cubic expressions and also solving a cubic equation. So let's look at factorizing the cubic expression first. Right, so in this basic 4, we asked to factorize 2x cubed plus 3x squared minus 11x minus 6 completely. Right, one method is to use trial and error, and that is to find suitable values of x to substitute into your cubic polynomial such that the remainder is 0, and then from there you can conclude so and so is a factor. However, we can use an easier and more efficient method, and that is to use your calculator, because the calculator has a lot of wonderful functions, and one of them is able to help us find a factor, not exactly find a factor, but we treat this cubic expression as an equation. And then I think depending on the types of calculator you're using, you can, if you're using the old Casio, I think it's a mode 3.3, and if it's using a new one, it's some of the functions. You can actually use it to find one solutions of x. Usually I would choose the integer value of x. Alright, so in this case here, if you cannot remember how to use the calculator, you can just PM me. Alright, so otherwise, first step is I'm going to let fx equals to 2x cubed plus 3x squared minus 11x minus 6. And if you use your calculator correctly, you would get x equals to 2 to be a solution for fx. So in other words, if you substitute your x to be 2, you will get remainder equals to 0. Right, so therefore, if x is equals to 2, by working backwards, I minus 2 on both sides. I conclude that x minus 2 is a factor of fx. Right, so earlier on, we know that a cubic polynomial can be factorized into a linear factor and a quadratic factor. Right, so x minus 2 is the linear factor, so therefore f of x can be written as x minus 2 times the quadratic factor. So quadratic factor will be in the form ax squared plus bx plus c. Okay, linear factor, it will be in the form ax plus b, but quadratic will be in the form ax squared plus bx plus c. They're standard. Alright, so I multiply with your ax squared plus bx plus c. So there are three unknowns here that I need to find, your a, b, and c. Of course, if you're very good with long division, you can just go ahead and use long divisions to find your quotient. The quotient is this quadratic polynomial that we are finding. Okay, and this step here, it's not new to you. I've already done a few questions early on, right? So we just basically take the first term of your linear times the first term of your quadratic, and that will definitely give you the first terms of your cubic polynomial. So that will get a equals to 2, and then we go on to find your constant term, right? Constant term. Negative 2 is a constant, multiplied with c is a constant, will gives you the constant term of a polynomial, which is negative 6. Right, and you get c equals to 3. So the more troublesome part is finding the value of b. So like what I've explained earlier on, you can either compare the x squared term or the x term. Right, so in this case here, I'll be comparing your x squared term. Right, so negative 4x squared plus bx squared. Make sure when you multiply finding your x squared term, make sure there are usually two of them, and the x term also there are usually 2 of them. You equate it to 3x squared. You divide by x squared throughout, you get negative 4 plus b equals to 3. So b is equals to 7. So putting all this back into your fx. Right, so this is what you get, x minus 2 times 2x squared plus 7x plus 3. And of course, this this quadratic factor, we can factorize it again into two linear factors. And that's how you actually factorize a cubic polynomial completely. Right, so usually, I'm not saying all the time, usually you would get three linear factors. Depending on the shape of the curve, sometimes you may get just one linear and then one, you may get a linear and then the other one is repeated, or you can even get a linear and then a no real root. Alright, so it depends on the curves. What I'm saying is that sometimes if the curve is in this way, then you would have three real solutions. If your curve is something like this, you see this is repeated, then you would have let's say x plus 2, and then the other one could be 2x plus 3 repeated. And sometimes your curve could be just something like this, so there's no real roots here. Okay, so it could be a linear factor, and then with the irreducible quadratic factor, could be x squared plus 3, something like that. Okay, right. Right, so let's extend our knowledge to solving a cubic equation. So whatever we have learned earlier on in factorizing a cubic expression still hold, right? We still have to find a value of x that satisfies the cubic equation. So you can use a calculator to find that solution. But first of all, let's name the polynomial. Let's call it f of x. Right, so as what I've mentioned earlier on, you can use the calculator to help you find a solution, and one of them is actually x equals to 2. So if you substitute x to be 2, you'll see that the remainder is 0. So if you work converting your solution x equals to 2 into a linear factor, you'll get x minus 2. So therefore x minus 2 is a factor. And a cubic polynomial is equal to a linear multiplied with a quadratic. Right, so here again we have to find the unknown a, b, and c. So this is not new to you. We've already done a few questions on that. So let's find the values of a first. Right, and go on to find the constant term. The constant is negative 2 times c, will gives you the constant term on the left hand side. Right, and then finally let's go on to find the values of b. So we can compare the x squared term or the x term. Here I would be comparing the x squared term. Right, so from there you get b equals to negative 5. So with all this information, we can just plug it back into your cubic equation. Right, and we can factorize this quadratic polynomial further into two linear factors. So therefore, the solutions for this cubic equation will be x equals to 2, 6, or negative 1. And these are the real roots. So in other words, if you were to sketch this curve, it will look like this. That's the solution at x equals to 2, one root here, at 6, at negative 1. And if you substitute x to be 0, you can find the y-intercept to be 12. Right, so your curve would look like this. Okay. Right, let's move on to the last question, and this is the intermediate level. Right, so part 1, we asked to find the values of k for which x minus 2 is a factor of the cubic polynomial. And if x minus 2 is a factor, using factor theorem, we know that the remainder will be equals to 0. Right. So like what we have usually done, let's give a name to your polynomial. Let's call it f of x, and then we're going to substitute x to be 2. Remainder is 0. Right, and if you simplify, just use your calculator to simplify this value. 2 minus 2 is 0. Simplify this, you would get 824. Okay, you'll get 2 squared is 4, so 4k equals to negative 24. Divide by 4 on both sides, so k is negative 6, so that is part 1, relatively easy. For part 2, alright, we asked to show that with this value of k, meaning after finding the value of k, we can substitute into your function and let's solve it. And we need to show that there's only one real solution. So let's go and do it. Alright, so we have found k to be negative 6, so let's plug into your cubic equation. So we have 3x cubed minus 6x squared plus x minus 2 equals to 0. And since we are told that x minus 2 is a factor, you can either use the long division to find your quadratic quotient, or you can actually use like what we have been doing for the past few slides, compare coefficients on both sides. So a cubic will be equals to a linear multiplied with a quadratic factor. Alright, so let's go ahead and find the unknowns a, b, and c. The first term will be ax cubed equals to 3x cubed, a will be 3. The constant term, give you c equals to 1, and finally I'm comparing the x term, so I can find b to be equals to 0. So putting all this back into my cubic polynomial, right, this is what I get. And to solve it means x minus 2 is equals to 0, or 3x squared plus 1 equals to 0. Now we see that this one has no real solutions, because if you go to minus 1 on both sides, this is what you end up with, x squared equals to negative 1/3. And if you square root a negative 1/3, the calculator will give you an error, because there's no real solution when you square root a negative answer. So therefore we conclude that since 3x squared plus 1 equals to 0 has no real solution, x equals to 2 is the only real solution for this cubic equation. So these questions will end this video here, right? Do practice a few times, and I'm very sure that with the concepts learned, you'll be able to solve any problem sums in this chapter polynomial.